right, guys, this is Mrs. Lyons, and we are going to continue working on the final exam review packet. After some technical difficulties, we're back up and going. So I'm going to start with the middle of page 5, calculating molar mass. You guys are pros at this, so I'm going to go through it relatively quickly. But as you know, you look at the periodic table, you count the number of each element you have, and add them all together. So ammonium nitrate, I have 2 nitrogens, 4 hydrogens, and 3 oxygen. Nitrogen is 14.01, so that is 28.02. Hydrogen is 1.01, so 4.04. Oxygen is 16, so that is 48. So if we add that all together, we get 06, let's see, 16, 20, 2, 4, 8. 80.06. 80.06, and remember our units for molar mass are grams per 1 mole. All right. Calcium phosphate. So we have 3 calcium. Calcium is 40.08. Remember this 2 multiplies through, so we have 2 phosphorus. Phosphorus is 30.97. And then we have 2 times 4, which is 8 oxygen, so times 16. All right, if I do that math, 3 times 40.08 is 120.24. 2 times 30.97. 61.94. 8 times 16 is 128. So if I add that up, I get 81013. So 310.18 grams per mole. Last one, we have 6 carbon. 72.06, 12 hydrogen, which is 12.12, and 6 oxygen, which is 96, which gives us a grand total of 180.18 grams per mole. Okay, so very quick molar mass, because you guys, like I said, are good at it. Identifying groups on the periodic table. So you should be able to look at the periodic table and know, first of all, if something's a metal or a non-metal or a metalloid. And then if it's an alkali, metal, alkaline earth, transition metal, metalloid, halogen, noble gas. Okay, so chlorine is in group 7, or excuse me, group 17. So chlorine is a halogen. Since it's on the right side of the periodic table, it would also be classified as a non-metal. Okay. Barium is in group 2. And group 2 elements are alkaline earth metals, which then, of course, that obviously is a metal. Copper is in that middle section, the D block, so it is a transition metal. Again, the name tells us that it's a metal. Jumping over here, neon is in group 18. That makes it a noble gas. Noble gases are all nonmetals. Potassium is in group 1. It is an alkali metal, which tells us it's a metal. And then boron is in group 13, and it touches the stair-step line, which tells us it is a metalloid. Okay. Compounds indicate whether they are ionic or covalent. Remember, an ionic is going to be made up of a metal and a nonmetal. Covalent are nonmetals only. So carbon dioxide, carbon and oxygen are both nonmetals. So this is a covalent compound. Sodium is a metal. Chlorine is a nonmetal. That makes that ionic. Aluminum and then nitrate. Anytime you have a polyatomic ion, it's an ionic compound. Okay. Carbon, hydrogen, oxygen are all nonmetals. That makes that a covalent compound. Nitrogen and hydrogen, nonmetals, so covalent. And then finally, barium is a metal, phosphorus is a nonmetal, so that makes that ionic. All right. For each element, give the number of protons, neutrons, and electrons. Okay. So just a quick refresher, the atomic number on the periodic table tells us the number of protons. In a neutral atom, it also tells us the number of electrons. The mass number gives us the sum of protons plus neutrons. Okay, so aluminum 27, aluminum is in group 13, and aluminum is element 13. We don't really care about what group it's in. We really want to know the atomic number is 13, which tells us aluminum has 13 protons, also 13 electrons. This is the mass number. So if we take 27 minus 13, that tells us we have 14 neutrons. Okay, sodium is element number 11. That tells us there are 11 protons, 11 electrons. Again, the mass number is right here, so 23 minus 11 is 12 electrons. All right. What is the atomic number for a carbon atom with 6 neutrons? Okay. Carbon is element number 6. So remember, the only thing that tells us the atomic number is the number on the periodic table. The neutrons don't matter for atomic number, so atomic number is 6. What is the mass number of a nitrogen atom with 8 neutrons? So if we look at nitrogen, it's element number 7, which tells us it's got 7 protons, and then 8 neutrons. So 7 plus, oops, sorry, you can't see that. 7 plus 8 is 15. So there's mass number is 15. What is the mass number of calcium 40? When you see something written in this hyphen notation, the number after the hyphen, we're going to draw an arrow back up here to the mass number. This is the mass number. So the mass number is 40. Okay. Let's see, how many protons and electrons in each of the following ions? Okay, so here you have to remember that electrons are negative. So if we add electrons, we end up with an anion. If we subtract electrons, we end up with a cation. And of course, we know that cations are positive. You can't see me, but I'm doing my little paw. All right, so calcium is element number 20. So calcium has 20 protons, and if it was a neutral atom, it would have 20 electrons, but it's not neutral. It's got a +2 charge, which means it's lost 2 electrons, so it's got 18 electrons. So 20 minus 2, 18 electrons. Nitrogen, element number 7. So it has 7 protons. This is saying it has a -3 charge. That means it's gained 3 electrons, which means there are 10 electrons in a nitride ion. Manganese, Mn, is element number 25. That tells us it has 25 protons. It's got +2 charge, so it's a cation, which means it has lost 2 electrons. So it's going to have 23 electrons. Potassium. Uh-oh. What did I do? Oh, shoot. Am I still sharing? Let's see. My screen just went wonky. Let me get us back there. Okay, good deal. We are still sharing. Okay. Whew. All right. Back to this. Potassium. Potassium is element number 19. So potassium has 19 protons. Since it's got a +1 charge, it's going to have 18 electrons. Selenium, element number 34, 34 protons. -2 charge means it's gained 2 electrons, so 36 electrons. And then finally, aluminum is element 13. So it's got 13 protons. +3 means it's a cation, so it's lost 3 electrons. So that is going to be 10 electrons. All right, number 29 asks us, what is the charge on the iron in each compound? Okay, so what you have to do is you've got to look at the anion, okay, because the positive charges and the negative charges have to cancel out. Okay, so if we look for sulfate on the back of our periodic table, what we will find is sulfate has a -2 charge. Okay, so since there's just one sulfate ion, the iron has to balance that -2, so the iron is going to be +2. All right, the next one, letter B, iron chloride. Okay, so again, chloride, if we look on the periodic table, forms -1 ions. We have 3 of those. So that's a total of -3. We have 1 iron that has to balance that, so the iron has to be +3. Okay, and I know some of you know that you can reverse crisscross this. You just should always make sure that it makes sense. Okay, for example, here's a perfect example. Iron oxide. Okay, we know that oxygen has a -2 charge. Okay, if we tried to do the reverse crisscross, we would just take this 1 up there, but that's not right because oxygen has a -2 charge, so this iron has to have a +2 charge. And then FeS2, just like oxygen, sulfur has a -2 charge. Since we have 2 of them, overall it's going to be -4. That means iron has to be +4. All right. Okay, now I'm going to get a notebook for this because I did not leave enough room to do all of this math. So I'm gonna slide my notebook up here and look at these. So how many moles of calcium chloride are in 32.8 milligrams of calcium chloride? Okay, so we're going to start with what we're given, 32.8 milligrams of calcium chloride. Okay, now the first thing we have to do, so this is a mole conversion. The first thing we have to do is we've got to convert these milligrams to grams. So 1,000 milligrams is 1 gram. Okay, now we can convert to moles. And to do that, we have to look and we have to see that calcium is 40.08 is the molar mass. Chlorine is 35.45. I have 2 of them, so 70.90. That gives me a molar mass of 110.98 grams of calcium chloride. And that is equal to 1 mole of calcium chloride. Okay, so I'm going to cross off milligrams. They cancel. Grams cancel. That gives me moles of calcium chloride. So let's do the math. Let's see. 32.8 divided by 1,000 times 110.98 gives me a number 3.640. We have 3 sig figs in our given, so our answer is going to be 3.64 moles of calcium chloride. All right, so let's look at the next one. I did something wrong with that problem. 32.8 divided by 1,000 divided by 110.98. I don't know what I just did. I guess I could look back at my video and see, but I just looked at that and realized that is a wrong answer. So 32.8 divided by 1,000 divided by 110.98, what I get is 0.0009296 moles. All right, and if I want to write that in scientific notation, 1, 2, 3, 4, I would have 2.96 times 10 to the negative 4th moles. All right, I need to pay more attention before I confuse you guys. All right, that was number 30. Number 31 says, how many carbon atoms are in 3.8 moles of CO2? Okay, so you got to do a little creative thinking here. So 3.8 moles of CO2. The first thing we need to do is we need to figure out how many molecules there are. Okay, so 1 mole is how many molecules? Okay, so 1 mole of CO2 is 6.02 times 10 to the 23rd molecules of CO2. Okay. Now it's asking us how many carbon atoms. So here's the conversion you need to think about. 1 molecule of CO2 contains 1 carbon atom. Okay. If we were looking for oxygen, we would do 1 molecule of CO2 is 2 oxygen atoms. Okay, so that's how you are going to do this calculation.